Hey guys, welcome back to the shop. Frank here, working on the Cub Cadet mini bulldozer. If you missed the last episode, here's the status of the tractor as it sits right now. It's largely complete as a tractor. The work left for us right now is to mount a blade to the front of it. Last episode, we fabricated this brush guard, and it really has a different purpose than being a brush guard, but it's to mount the hydraulic cylinders that will control the blade height right and left. So there'll be two hydraulic cylinders mounted on the outside of these two plates, and then we'll also have the top link mounted and my current plan is to have it adjustable to any of these three bars. So the mount for the top link can be moved to any of these three bars. These are solid 1-inch bar stock, and we've got a couple of plates which cover these openings down here on the bottom. Have not installed them yet, even though the holes for them are drilled and tapped. We'll wait to install them when we get to that point. So this episode we're going to focus on the lower lift arms that run from the side of the tractor out in front of the tractor, one on each side, and those will be what these hydraulic cylinders will connect to, and that allow us to lift the blade, either side of the blade, up and down. The blade. All right, guys, I'm testing out a new microphone system. We'll see how this works. Most of the time I'm close enough to the camera that the microphone on the camera works okay, but there are times when I'm not. And I do have a couple of sets of remote microphones. This is a new set, a Rode remote microphone. The other ones I have are larger and require a pack in your pocket and run a wire up to a lapel mic, and then the receiver is so big it's hard to mount to the camera. This is a GoPro Hero 3 Plus camera. Okay, so I've got to cut some of this 1/2 inch by 4 bar stock into shorter lengths to put on the plasma table, because my plan is to attempt to cut the lower lift arms out of this material, and they will go from the brackets on the side of the frame out to pins on the blade, the frame of the blade. And they're going to be approximately 30 inches long. Now you can buy lower lengths, and I saw some at the Tractor Supply here locally. They were much longer than I needed. They were 35 inches, and I mean, you can't cut them down, so I mean, I suppose you could, but and they were like $80, $75 a piece. And I mentioned in the previous episodes, I was waiting for these components from the tractor. It's actually like Uncle Bob's Tractor Supply or something. Anyway, I found these weld-on connector points, and what they are, it's a circle, a disc with a ball mounted in the middle of it that has a hole through it, and the ball can move, so it gives you some flexibility in that joint. And that's what you normally use on the end of the lower control arms on a 3-point hitch. And that can be welded to, it's a replacement part actually, I guess you would be for repairing an existing lower arm. So I'm going to my plan is to cut this 1/2 inch bar stock to the appropriate shape and length, and then weld those connectors on the ends. So I'm going to cut this bar stock into 2 pieces, 36 inches long. And that'll give me extra, actually I probably only, my length should be 30 inches, I'm calculating about 30 inches long, so maybe I just cut this to 33. Cut 2 pieces, 33 inches long. All right, so of course my new Rode microphone battery died. I've moved over here to the plasma table, and I just want to show you what's left in the table after you've been cutting metal for a couple of sheets of metal. This is the dross and slag that falls to the bottom of the table. Most of this came from cutting the 3/8 inch sheet here and the sheet of 1/4 inch I had on the table before this. And of course there's large clumps of slag. Most of that's come from the 3/8. Some of the pieces that I'm picking up here, while they do crumble, I don't get slag like that from 1/4 inch or the 1/8 inch metal. This has all come from the 3/8 inch material. So I clean out the table periodically when it gets, when you get a bunch of stuff in the table, it just it's time to clean it out. And of course a lot of the little squares and circles come from the pierces and the holes that are cut in the material, and they just drop to the bottom of the table. So I pick up the big pieces here because they wouldn't get, they would clog up the shop vac hose. Being too big to pass through the hose, they would, create a problem. But the smaller chunks will go right through the hose into the shop vac. And of course there's a lot of finer debris in the bottom of the table and reaching. It's easier obviously to clean this out when there's not a sheet of metal on the table, but this piece of 3/8 I'm not sure whether I'm going to cut any more of it, and it's kind of a evolution to move, so I'm just going to go ahead and pick up what I can out of the table with the sheet still on the table. And most of the debris between the slats and the table is in the front left corner there where the holes are cut through the sheet. Most of the cutting I do is on the left side of the table, and you can see, you know, the way the slats are damaged more on the left side than they are on the right side. I usually start all my cuts over there in the left front corner. Most of the wear is, and most of the debris in the table. So lifting up the sheet a little bit with the davit, I can clean out the debris. So I'm getting ready here to refill the table so I can start cutting the 1/2 inch material for the lower support arms for the front blade. I mentioned earlier that my gyroscopic stabilized camera mount had lost its mind, and it turns out, well, look who we have here. We've got Brutus. What a good boy. My good puppy. The gyroscopic mount, which I'm using now actually, apparently a piece of metal filings got into the mechanism and bound it up. And when it's bound up for any period of time, it quits, turns itself off. So I think that's what was happening. All right, where's Butchie? I wonder if you and Butchie would like a treat. What's wrong with your ear? You're shaking your head a lot. And of course, Butchie heard that. He could have been halfway across the yard and heard that. Do you want a treat? Do you want a treat? No. You can get down. Look at you. Look at you. Climbing up. Let's see. All right, just a minute. All right. You got one. But you got the other. Butchie? Come on, Butchie. You being a good boy, huh? You chasing any squirrels out there? Did you get any squirrels today? How about birds? Did you chase any birds? Yeah. You probably did. You're a good boy. Not because you chase birds, but because you chase squirrels off of Mommy's bird feeders. My wife has a lot of bird feeders out, and the squirrels just we have several bird feeders which are squirrel proof, and they can't mess with those. But a lot of the other bird feeders, like stuff you put up for a woodpecker or, you know, larger birds, it's not easy to make them squirrel proof. Because we have raptors here, there's red-shouldered hawks, red-tailed hawks, and of course the bald eagle. I guess there's more than one bald eagle. The songbirds won't venture out very far out into the open. they want to stay near bushes for cover. So you have to hang your bird feeders basically, you know, on the branches of a bush or very close to a bush, so that they feel safe. Otherwise they won't come to the feeder because the raptors. So we don't have nearly, I mean, we're in a coastal area here, mid-Atlantic coastal area, and there are many fewer songbirds than there were when we used to live further inland. And we used to live 100 miles west of here, so 100 miles from the coast. And there were, I mean, the songbirds, blue jays, cardinals, just all kinds of birds were all, I mean, all over the place. There was nothing to have 10 pairs of cardinals on your bird feeders in the winter. Here, you know, the most we ever see is 1 or 2 pair, and the many fewer songbirds. So it's interesting, the difference, and just in just 100 miles, and it has to do with the raptors. We had hawks at the other, you know, in the other house too, but for some reason here, it just the songbirds are much more wary. All right, looks like the boys have decided to eat dinner. It is. Yeah, it is. It's 5 o'clock. All right, I'm going to head in the house. We'll come back tomorrow, or maybe tonight, but probably tomorrow, and work on the lower lift arms. I have not cut 1/2 inch on the plasma table yet, so part of my plan for tomorrow is to fill the table, of course, and to practice cutting the 1/2 inch. I have to make several practice cuts to determine the proper torch speed. I don't know whether I can pierce the 1/2 inch or not with the torch. I am told by the online forums that it's best to do an edge start. So the parts I need out of this can be started on the edge, but it would be nice to know if I can pierce and cut a hole in the 1/2 inch. 1/2 inch, I am told, is about the limit for my torch, which is a 45 amp torch. So, okay, we'll come back tomorrow. All right, you can see it's not the easiest thing to get in and out of the seat, but I do have some folding footsteps that I was considering attaching got a pair of these folding footsteps. You would flip up when not in use, flip them down when you need to use them, and attach them maybe right here, something like that, or maybe up here. So I haven't decided what I'm going to do with that. We'll figure it out. All right, one thing I want to check is the angle of the blade. Need to be sure it can pivot right and left. All right, so it can angle at least that far. It can go even further, but that's probably sufficient. All right, so this gives a kind of an idea of the location of the blade relative to the front of the dozer. Got a couple of wet puppies here. It was snowing outside a little bit this morning. Then it turned to sleet. And now it's basically raining. We're supposed to get a good bit of rain. So the inclement weather is the reason I'm not running the plasma table today. I don't want to chase the dogs, force them to be outside. I mean, most of the time in rain, I mean, they don't care, really. Snow, they'd rather be out in the snow playing, but I don't like to force them out there. Plasma table, air compressor, welder scares them, so they run outside. Most of the other power tools are used to hearing. Most of the woodworking tools, I mean, they don't like them, but other than the planer, the wood planer is so loud that definitely chases them out. But most of the other power tools, they don't care too much. They're so used to them. All right, so I've got this blade mount shortened about a foot, and I think that's in a good position like that. I think I'm gonna, I mean, there's still some adjustments to it I'm gonna make, improve its overall appearance. I'll probably round over this corner or cut it off at an angle maybe. I don't know yet whether I'm going to weld it together or whether I'm going to put a couple of plates and bolt it in that orientation. I'm just going to leave it clamped together for the time being. My next focus is the lower support arms and trying to get that sorted out, and then the hydraulic lift cylinders. So I think I said earlier that I was going to focus on the lower lift arms for the blade in this episode, but as I work on the blade, and I've come to the conclusion that it's premature to make those arms. First of all, I don't have the connection points that I ordered, so I'm waiting for those. But I think I've got some more work to do on the blade mount. And the more I think about it, the more I feel like I need to shorten the mount, compress it some more, that is. It's right now the way it is. I think I was working on a plan last night. I'm not sure I'm going to be able to do it. There's my brew coming in to check on me like every 20 minutes. I'm not sure I can. I'm not sure I can do it. I think I can. I would like to reduce this distance even more, bring this bracket closer, maybe cut this distance in half again, and extend the support down to the bottom of this. See, this blade is held by a tube going through this bracket, a 3-inch diameter. Actually, it's 2 7/8, but 3-inch diameter. You want to let me do my work here? Why don't you go play with Butchie for a little bit, huh? You're a good boy. You're my good boy. All right. So I want to bring this bracket in even closer. And the only limiting factor is the blade angle, how much I can angle the blade so it doesn't hit this. So I think I've got some more work to do on this. I would like to do that before I actually fabricate the lower lift arm. What I can work on is these lift arm support brackets. I know what size hole I need to drill here, so I'm going to go ahead and finish fabrication on these two brackets. So I'm going to do that now. All right, I'm setting up to drill the holes in these brackets. If you didn't see in the previous episode, I have two of these brackets we fabricated last episode or the episode before, I don't remember exactly which. But these will support the rear of the lower lift arms that will take the bulk of the stress from the blade pushing. Almost all of the blade pushing forces transmit through the lower arms, lower lift arms. So these brackets need to take all that force, which is why they're pretty robust, probably excessively robust, but better, more robust than not enough. All right, so I'm going to drill holes. Let me change out this, put a chuck in. I've center punched a hole. The location is not critical. There'll just be a pin going through here. The support arm will. This isn't the lower support arm, but it has the same type of connector. It'll fit in there like that. So all you really need is something close here, plenty of room behind it for it, and room for this to pivot. So Alright, so here are the two lower arm, call them thrust brackets maybe, because they'll take the thrust force of the blade through the lower arms. Alright, so that pin goes in there, and then there'll be a bolt or a pin through here. Alright. Alright, so this one goes on one side of the tractor, this goes on the other side. They both face this direction. The lower lift arms will connect to these pins. And I'm still thinking about the attachment method for attaching these to the frame. I'd like to spread the load out over as large an area as possible. So yeah, I'm thinking about welding them to the frame. I think I can weld at least the front and back. I don't know if I can reach the top. I can probably reach the bottom. So we'll see when we get to that point the best way to attach them. Not too worried about that right now. But these are, you know, other than drilling the hole in the pin, you know, these are mostly complete. I do need to do that though, so I think it'd probably be a good idea to center these up and see what the best way to do this is. I'm rethinking my plan here for retaining these pins. Since having difficulty, you know, drilling all the way through and then finding a pin that will fit that is probably going to be an issue. So the other choice, what I don't want to do is I don't want the pin to come out like that. So the other possibility and the other choice is to put a pin, a cotter pin like this through the shaft right there. So that would hold it in position. It would keep it from pulling out. Can't go anywhere in this direction because it's against the side of the tractor frame. And I think that kind of simplifies matters a little bit. So I think I'm just going to do that. I'm going to just drill, center punch the shaft here. Alright, so I'm going to drill these shafts, put them back in the mill, and for these pins, and this is a 0.1, 0.15, so we need to drill a little bit larger than that. That would be, we'll drill 5 30-seconds, which is 0.1. .1562. 0.1562. This is 0.146. So 5/30 seconds should give us clearance. Put these back in the mill and drill those holes. Alright, so using the edge finder, I can find the center of the shaft using my DRO. Got 1.073, which would be 1.075 if it were exactly right. So maybe the shaft is a couple mils off. So we want to go to 0.5375, which is half of that. You have to take the diameter of the shaft. The edge finder is 0.2, 2/10 of an inch in diameter. So 200 thousandths or 20 hundredths, 0.2. So you add 0.2 to 0.8, 0.875, you get 1.075. All right, let's 0.5. 375. Right there. Okay, so this is the change. We've got the cotter pins, and that will keep this shaft from coming out and should not interfere with the connection that goes on this shaft. So it'll be restrained over here by the body of the frame of the tractor, so it can't move out. All right, I think that's a simpler solution than trying to work a pin through here. All right, guys, that's a wrap for this episode. We finished up the mounting brackets and made some progress on the blade mount, and I've got some changes I'm going to make to that. We'll do that next episode. We'll come back next week working again on the blade support and the brackets for the hydraulic valves. I've got those pieces all modeled in Fusion 360 and the G-code generated, so it's a matter of putting a 1/4 inch steel on the plasma table and cutting the parts out. So we'll work on that. All right, appreciate everybody watching. Leave a comment, subscribe if you haven't already. We'll see you guys next time.